Hello and I welcome you to my ventures. I hope you all are doing fine. So today we are going to discuss about a special algebraic integral, and it is special indeed because later on you will find out that this particular integral form can be used in certain questions of NCERT. Okay, so without wasting any time, let us move on to the form and its procedure. As we can see, these three types of integration are our forms. Now, if I may pronounce it, I can pronounce it as integration of quadratic divided by a biquadratic form. Now, there are certain conditions associated with it, such as the quadratic form cannot consist the x term. You won't find the x term in the quadratic form. Okay, you can observe here. Okay, and also it may be a constant itself 1 or any other constant it may be, but if we have a quadratic, then obviously in this form x term will be absent. And similarly for the biquadratic, you can observe here that we don't have the x cube term as well as the x term, so x cube and x term are absent. So with this certain precondition, let us begin our procedure. Alright, so now in step 1, this is a very simple form. All you have to do is, first of all, you have to divide both the numerator and denominator by x square. And after that, we will express in step 2 the denominator as the sum or difference of two squares. Okay, then you will see that a part of the denominator can actually be substituted. Okay, now before going to a question, now observe this note. And this is what I was talking about. If the denominator can be factorized, then the integrand can be taken to partial fraction. That means certain questions in partial fraction which satisfies this given condition of the form, this condition which we were talking about. Okay. Now, if they satisfy the condition, then that partial fraction question can be converted into this form. We will later on check it out. Alright. So now let us go to the first question. Okay, so our first question is integration of x squared plus 1 divided by x to the power 4 plus 3x squared plus 1. Here we can compare and see that actually it resembles the form. So without wasting any time, let me divide both numerator and denominator by x squared. So in numerator you will now get 1 by 1 plus x squared after dividing by x squared. And in the denominator you will have x squared plus 3 plus 1 by x squared dx. Alright. Now the second step comes. Now we will form a whole square, sum or difference of two whole square. Okay, for that we will be using completing square. Alright, now let us take x squared minus 2 times of x into 1 by x plus 1 by x squared. Okay, so you can observe here that we have got our x squared term, we have got our 1 by x squared term, but this term which we don't need, as the previous expression does not contain this term, so we have to cancel it out, but we need it to form the completing square. Alright, now so I will here add a 2, get rid of that minus 2, and beforehand we had a 3, so we will add a 3. We had a 3, so we have to add a 3. Now you can say that okay, now we are balanced. Now the numerator will remain same, 1 plus 1 by x squared dx. Now many of you might be thinking that why we have chosen to take a minus sign ahead of 2. With that we will be getting here a minus b whole square form, whereas we could have taken a plus sign which would have given us a plus b whole square. The reason behind it we will come to know later on. Okay, so let us proceed with this, and you will later on come to know why we have taken minus. Alright, so now you can see here we are going to get x minus 1 by x whole square plus 5, and the numerator will remain same, 1 by 1 plus x square dx. Now observe that due to the fact that we have chosen to take minus, now x minus 1 by x can be substituted as t, suppose, and you are going to, after substituting and differentiating, you are going to get the exact numerator. Now if I would have taken plus instead of minus here, I would not have got the numerator. Okay, that's the reason behind it. So it is pretty basic, simple. Okay, so let me remove this. Now let me substitute and make the numerator as d of x minus 1 by x, and you can verify that you are going to get exactly the denominator. Alright, so almost done. So you are going to get, here we will write here root 5 square. Alright, so now, so we have a form of integration dt by, we can write that also, integration dt by t square plus a square, which will be giving me 1 by a tan inverse t by 2. Alright, so using that form, you will write here 1 by root 5 tan inverse x minus 1 by x divided by root 5 plus c. Okay, so that's it, that's your answer, but you can simplify it a step more. So 1 by root 5, 1 by x root 5 plus c. Alright, so our second question. Now, as you can see here, the denominator is in a factor form. Okay, so we have x squared plus 4 with the product of x squared plus 9. Now, due to this fact, one may think of taking this form to partial fraction. Okay, and it can be taken if you will take x square equals to say y, okay, for the only the expression, not as substitution, and you can reduce it to partial fraction, but we won't go in that way. Okay, because it is included in the NCERT, many of you know how to use that, but in this video we are going to express this form in special algebraic integral as we have discussed today. Alright, now let me expand the denominator, that is, let me multiply and break the denominator and see what we will have. So we will have x to the power 4 plus 13 x squared plus 36 dx. Alright, now if we take a look at the form which we had discussed earlier, okay, so you will see here, you can see here that we have integration x squared divided by x squared plus x to the power 4 plus 1, or this form or this one. Now take a closer look here that we have x square common in the numerator. Okay, you have x square common in the numerator. Then that x square should be expressed in this way, half of x square minus 1 plus x square plus 1. And similarly for this form, now if you take a look here, we have a coefficient lambda of x square and a constant a square, but in the previous one we had 1 as coefficient of x square and minus 1 as x square and constant fixed as 1. Okay, so that means in case you get a different number ahead of x square and the constant, then you will express x square, the numerator part, as half of x square minus a plus x square plus a. Okay, now if you compare what we have got here, it will resemble the form that we have now just looked on. So following the form, let me express x square as half of x square minus 6 plus x square plus 6 whole divided by x to the power 4 plus 13x squared plus 36 dx. Now why we have chosen 6 here? Because of the fact of 36. Okay, as you can see here in the form, if we have a squared, then we have to express in terms of a. Similarly, as we have here 36, so we have expressed as a squared, that is 6. Alright, now what? Now let me split the integration with respect to the denominator. Okay, so we will have half of integration x square minus 6 divided by x to the power 4 plus 13x squared plus 36 dx, and again half of integration x squared plus 6 divided by x to the power 4 plus 13x squared plus 36 dx. Okay, now what? Now if you see here, we have actually converted into the main form, okay, as the main form. So now we will be able to divide by x squared. Now let us divide the numerator and denominator by x squared. So you will get here 1 minus 6 by x squared divided by x squared plus 13 plus 36 by x square dx. Similarly, here you will have half of integration 1 plus 6 by x square whole divided by x square plus 13 plus 36 by x square dx. Alright. Now after dividing actually by x square, now we have to form the sum or difference of 2 square in the numerator. Now observe here, as we have seen in the previous case, if we have a minus sign here, we have to form the completing square as a plus b whole square. Let me tell you that it will be in the form of a plus b whole square. And if you have an addition sign, then the completing square should be in the form of a minus b whole square. So what we will have here, 1 minus 6 by x square, okay, and the denominator we will write here x square plus 2 times of x into 6 by x. Now you have to form here 6 by x, because now we will write here 6 by x square. Alright, so I hope you are getting the point. Now if you look here, we have a 12 which you have to subtract. So minus 12, and we had a 13 beforehand. Okay, this 13, so plus 13 plus half of. Similarly, for the second part also, we will have here 1 plus 6 by x square whole divided by x square. Now we will form here minus 2 times of x into 6 by x plus 6 by x square. Okay, now you have to add a 12 here plus 12, and for the previous 13 it will be plus 13 here. Alright. Okay, so coming back to the first integration. Alright, we will get here a dx and also a dx here. Okay, so we will have here half of integration, the numerator will remain same, and we will have here x plus 6 by x whole square plus 1 plus half of integration. Now you can see that we have formed the denominator as the sum of 2 squares. Alright, now almost done. Okay, so we will have here half of integration d of x plus 6 by x. That is, we have actually taken x plus 1 by 6 as t. That means we have substituted this. Okay. Alright, so you will have here x plus 6 by x whole square plus 1 square. Okay, in the second integration, we will have half of d of x minus 6 by x divided by x minus 6 by x whole square plus 5 square. Now, in the numerator, what we have written, I have many times advised you that you should verify the numerator, because we have actually taken a shortcut. We have not substituted, literally we have not substituted the denominator part, but actually we have taken a shortcut. So it becomes very essential for you to verify it. Alright, so now we have here half of tan inverse x plus 6 by x plus half of, so you will get here 1 by a tan inverse x minus 6 by x by 5. So that's it, that's your answer, but you can simplify a bit. So you will have here half of tan inverse x square plus 6 by x plus 1 by 10 tan inverse x square minus 6 by 5x plus c. Okay, so here we have completed the question. And by the way, if you approach in the partial fraction form, you may get a different form of answer, but don't worry, both will be correct if your approach is accurate. Okay, so you have this final answer. And so let me end the video. Thank you.